All right, so like I said, each one of these, this left side here is just a checklist. This column is telling me what we proved, and then this is just an example of what it would look like. So the first one, the linear pair perpendicular theorem. What it says is that you have two lines that intersect to form a linear pair. A linear pair forms a what? A straight line. So I have two angles that form to make a straight line. Thank you. Thank you. All right, so we got to check for the first one. Two lines form to make a linear pair. Then they say that angle 1 and angle 2 have to be congruent. They might not always be labeled angle 1 and angle 2 on your worksheets. Just know that those two angles have to be congruent. When I look over here, what do these little curves mean if you see these on angles? They're congruent. Like they're like telling me that angle and that angle is congruent with each other. Okay? So we meet that criteria, check. So then we know that these two lines are perpendicular with each other. What does perpendicular mean? They intersect and form a right angle, right? A 90 degree. Because think about it this way. If this makes a straight line with each other, and each of these are congruent, I'm going to say the straight line's 180, and each one's congruent, so divided by 2, each one's going to be what? 90. Okay, so these are perpendicular lines. All right, that should be pretty straightforward. Even without the theorem, you should be able to pick that up pretty easy. Okay. All right, the next one. Perpendicular transversal theorem. So this one says, do we have two parallel lines? When I look at that, does it have parallel lines? Yes. What proves that those lines are parallel? Okay, these little red arrows, right, show me that they're parallel with each other. Okay, so check. Do we have a transversal crossing the parallel lines? Yes. Brady, which one is the transversal? Which letter or which line?
K.
K? Do y'all agree with that, class? Nope. It's not K. Andrea?
J?
J. Why is it J?
Because it cuts through the two lines.
It cuts through two lines, right? So Brady, see, the reason that K is not one is because it only intersects one.
Okay.
So it's got to intersect two of them. Okay. So we do have a transversal, and it's J there. Then we have to have a transversal perpendicular to one of the parallel lines. Jules, do we have at least one? Our transversal letter J, is it at least perpendicular to one of those lines? Which one is it perpendicular with? H. Okay, so we got this. All right, so we hit all our criteria. If that's being said, what we know is that the transversal is also perpendicular to the other line. So that means that this is perpendicular here, but it's also perpendicular here. So we know that this one's going to be 90 as well. Okay? We proved it using that theorem. All right, and if you just think about it, parallel lines are always the same distance apart, correct? So they're always the same angle. So if one's tilted like this, the other one's going to be tilted like that. So if you have a straight line going through it, those lines are going to be the same angles, right? It's going to make the same angles on each one. Okay. If I zoomed in here, what kind of angle is this one and this one? They're right, but we just took a test on this. Which one of our special angle pairs are those two? What are they? Corresponding. And remember, if they're parallel lines and we have them corresponding, they're what with each other? Congruent. So that means if one's 90, the other one's going to be 90 as well. So that's another way of looking at it. All right, last one. Lines perpendicular to a transversal theorem. All right. So do we have two lines there? Yeah, we got two lines. Yes. Angie, do we have a transversal going through them? And what's the letter of the transversal? P. P is a transversal. It's crossing the 2. And Mateo, does the transversal, is it perpendicular to both lines it's crossing through? Yes. They both have a 90. So what that proves is that the 2 lines are actually parallel with each other. Okay, if it's got a 90 here and a 90 here from one line going through it, then M and N are are parallel with each other. Okay? Any questions on this, on the theorem part? All right, let's go to some examples. Example 1, find the value of angle 1. All right, so these first couple examples should just be kind of a review of what we've been doing before, right? So we know the big angle adds up to equal how much, Monica? How much does the big angle equal here? How much? No, so remember we look at this right here. What does that tell me? It equals how much? No, this the little box. There you go, 90, okay? So this is 90 degrees. All right, and Paula, if the total is 90 degrees, what do I do to find angle 1? So if these two add together to equal 90, we go backwards and we say 90 minus 65. So how much does angle 1 equal, class? 25. So measure of angle 1, 25 degrees. All right, this one. Mandy, what does this little symbol mean that's between line FG and line GH? It means they're perpendicular. So if FG and GH are perpendicular, then that means all their corners are 90-degree angles, right? Okay. So when it tells me to find X, so if I zoom in and just focus on this section here, we know they add together equal 90. So, Andrea, tell me, what is the equation going to look like that I'm going to write out?
X plus 14.
Uh-huh.
And then, I'm not sure, but maybe plus 63.
Plus 63
Equals 90.
equals 90. Is that correct, class? Yes. Because we know that this one and this one add together equal 90, so we say that one plus that one equals 90. And then we just got to find X. All right, so Angel, what is my next step to find X? How are we going to find this, Lucas?
You add it together.
Add what together?
14 and 63.
14 and 63. So I have an X, a 14 and 63, and we call that combining like terms, right? Nothing with the X, but the 14 and 63 add together, and what does that give you? 77. Then Brady, what's the last step here?
You subtract 77 from 90.
Subtract 77 from 90. X is equal to how much, class? 13. All right, I like these. These, you got to think about everything, a lot of things that we learn, not just one thing. So I've got 5 missing angles here. So let's write them all out. Measure of angle 1. Measure of angle 2. Measure of angle 3. All the way to 5. Jules, pick one angle and tell me what it equals. I don't care which one you pick, just pick one. All right, he says angle 1 is 90 degrees. How do you know it's 90 degrees? It's got the little symbol, right? Okay. All right, Hernan, pick one and tell me which one, how much it equals. Say which one? Number 2. And how much does it equal? Pick one. What's angle 2? Uh-uh. Yes, it's 60. How did you figure that out? Okay, so we know if this one is a right angle right here, that means it's a right angle all the way around, right? So then angle 2 and the 30 add up to equal to 90, right? So we go backwards and say 90 minus 30 is 60. Ready?
Number 5, 90.
Number 5 is 90. How'd you figure that out?
Because it's a right angle.
Because right angle, or it's, let's say it's perpendicular. It's perpendicular, or what kind of angle does it make with this angle 1 here? What are they? Vertical angles, right? So you can say perpendicular or vertical. All right, somebody else want to volunteer? Andrea?
Number 3, I have 30.
3 is 30. Why?
Because it forms a vertical to 30.
Good. The angle, like if we were to highlight angle 3 right here and the 30, they make an X and they're across from each other, right? So that's a vertical angle. Vertical angles are congruent. So it's 30 degrees because it's vertical. And somebody want to try number 4? Brady?
20.
20? How'd you do that?
Because 40 plus 30 is 70, and then you need 24 to make 90.
And then 90 minus 70. So we know that this whole thing right here is 90 degrees. The 3, the 40, and the 4. And angle 3 is 30 degrees, so 30 plus 40 is 70. And then 90 minus the 70 is 20. So angle 4 is 20 degrees. All right, this one asks, which lines are parallel? Erase this part in your notes. Like, it's not supposed to have those little arrows here. So we just kind of scratch it out or something like that. It's just supposed to be normal lines. All right, this is from that last theorem on the the bottom one on the front of your foldable, where it's lines perpendicular to a transversal theorem. So don't make this more complicated than what it is, okay? It's really simple if you just look at one line at a time. So what I always recommend doing is just cover, look, especially when you have multiple lines like this, I got to look at each transversal. So when you have 5 lines, there's multiple transversals, right? Because a transversal has a line that crosses 2 other lines at 2 different points. So I've got a bunch of lines that do that. So look at each one. For example, let's look at line L. Cover up all your other, don't focus on the other intersections, just the one that L's going through. And I ask myself, when L goes through, is it perpendicular or does it make a 90 on both of those? Just L? Is there a 90-degree symbol on both? No. Okay, so that one doesn't prove anything. So let's go to M. Does it have a 90 on both? No, that one doesn't prove anything. N? No, the top one doesn't have a 90, so that doesn't prove anything. All right, let's go to P. So cover up Q. Does P have, when there's multiple lines, does it have at least 2 of them that are are perpendicular? No, it's only got 1. So I'm trying to cover this up. What about line Q?
Yes.
What lines are perpendicular with line Q? M and N, right? So that proves that M and N are parallel with each other. Okay? So if you have a transversal and you have two other lines that are perpendicular with that transversal, those two lines that are perpendicular are actually parallel with each other. Okay? So our answer is going to be M is parallel with N. And it doesn't say to explain, but we're going to write with this. We're going to say lines perpendicular to a transversal theorem. Okay. So you can have multiple lines that are parallel with each other. This one only has one though. All right, then that theorem, lines perpendicular to a transversal theorem, is the explanation for it. So we're finding the distance from a point to a line. So I have this point up here, I have A. Then I have this line down here, line K. And I want to find the distance, how far apart point A is from line K. But I want the shortest distance. All right, I want the what's the shortest distance from it? I don't care how long I can go, how short. So for example, say line K was the street I lived on. I lived on K Street. And you're over there at house A. And I said, what is the shortest path from your house to my street? You would want to make a parallel line, a perpendicular line. Because the shortest distance is always going to make a right angle like that with the line. So here's some examples. I could get from A to line K that way, right? I could also go there. I could also go there. But every one of these pink ones I drew are longer than this black one that was already drawn. Okay, this is the shortest distance. It makes a 90 degree with this street. Okay? All these other ones get you there, but they're longer. We want to know the shortest distance. So it's always the one that makes the 90 with the line that we're going to. Does that make sense? All right, so let's look at some examples. So number 19. I have point A here, and I have line C. And I'm sorry, these are kind of bad examples. They're kind of blurry. So I have 2 points on point C, this one and this one. What I'm going to do is draw a line to each of them from A. So that one, and draw them as straight as you can. And then this one. So I know I always tell you don't assume. This one we kind of have to make a little assumption. Which line looks like it makes a 90 with the line, line C? Is it the blue line or the brown line? The blue one. That's going to be my 90. Okay? So I don't even care about this line. I don't care about that. I just care about the blue one. And I want to find out how far apart A is from that point on our line C. So when I look at A, what is the coordinate point of A? And you're going to have to look up here on the screen because yours is pretty much whited out.
2.
1, 2. And then what's the coordinate point on this point here on line C that we're going to? Not 0, 0.
0, -1.
Flip it.
-1, 0.
Negative 1, 0. Remember, you do your X, your left and right first, and then you do your vertical. All right, so once we have that, now we're going to find the distance between it. So we use the distance formula. Square root of x2 minus x1 squared plus y2 minus y1 squared. And you're going to use your calculator and give me the first decimal place. So remember, I'm going to label this x1, y1, x2, y2. All right, we're going to plug it in. Angel, what's my x2? One minus and the x1 is what? So x2 is 1, but what's the x1? Look at which one I got labeled x1. Negative 1. So it's 1 minus negative 1, which becomes what, class? Becomes a positive 1. 1 plus 1, right? Plus y2 is what, Monica? 2. Minus y1, Paula? 0. Squared. Now put that in your calculator and tell me what you get, the first decimal place. So D is equal to 2.8.